Hi, my name is Ben Berger, and this is my second video on Homework Zero. This is going to be Homework Zero Part 2. You have the pleasure of seeing me get to do my homework. So let's take a look at the questions. So here we have the first part. Define a method, hello name, that takes a string representing a name and returns a string hello, comma, with the name. Okay, simple enough. I'm going to go into my Ruby workspace. Define hello name. Should end that, although it's probably too many spaces. All we're going to do is we're going to return string hello, comma, space, plus name variable that we passed in. Well enough, let's try it out. Let's hello, here's my name, Ben. Hello, Ben. Perfect, that's what we wanted. Great. Part 1 done. Let's look at part 2. Define a method, starts with constants, takes in a string and returns true if it starts with a consonant and false otherwise. So if it starts with A, E, I, O, or U, it should be returning false. Okay. So now we go here, define and perfect. Okay. The first thing we're going to do is want to take S and make it all the same case. So let's do down case. And the exclamation point to make it work on itself. We could use a switch statement here. We could use a few things. We could use a regular expression. I'm going to go a simple route and just use if statements. Well, one if statement and with a bunch of ors. So if s 0, because we only care about the starting with, equal to, nice thing about Ruby is that you can string compare with an equal equals a, return true. Otherwise, return false. And that's incorrect. I want to do return false. Otherwise, return true. Okay. Or copy this over. We have our A, and let's copy this. A, E, I, O, U. A, E, I, O, U. Okay. And that should be everything. So now let's test it out. Let's start with consonants. And let's try hello. It does start with a consonant because H is a consonant. Now let's try ELO. And false because it recognizes that E is a vowel. Let's what if we did ELO? False again, because it recognizes even uppercase or lowercase both work. Fantastic. Okay, and that's part 1 and 2 done. Now let's look at part 3 of part 2. It's going to be a little more complicated, but define a method binary multiple of 4 that takes in a string and returns true if the string represents a binary number that is a multiple of 4. Be sure it returns false if the string is not a valid binary number. So now we do the same thing, define, and that. The first thing that we always want to do is check and make sure that it is a binary number. If binary. We're going to go through for position in 0 to s dot length. And make sure to end that. Excuse me. If s, fs position does not equal 0, and does not equal to 1, return false. So this will check and make sure that in every position we have a 0 and we have a 1. So now I'm going to reverse the string, make it easier to work from, because our string of binary is now going to be turned around. So that I can work from the back, because that's, I think, the easiest way to work from binary. And I need to make sure to end this if statement. That was my mistake. So one easy way to make sure that something in binary is divisible by 4 is by checking to make sure that the last 2 digits in the binary string are zeros. That's the easy way. It's a simple way. I'm going to do a little bit less complex way of checking that. Well, I'm going to do a little bit more complex way of checking that. That can work with any number you want to put in here. And not just 0, can be a 5, can be whatever. So the first thing we're going to do is we're going to translate the string binary into a integer. So we're going to have my int is equal to 0. Everything's going to be stored in here. Now we're going to loop through the string again. For position in 0, 2. Keep doing that. 0, 2, s dot length. Should end that. Now here, there's going to be an interesting case that's going to happen with the very first digit. So let's say we had puts 1, 0, 0, 0. So in binary, this first 0 is going to be 2 to the power of 0, and then 2 to the power, and then the next one is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. The problem with 2 to the it's actually going to be 1 times or whatever the number in here times 2 to the power of 0. The problem with 2 to the power of 0 is that it's going to give us a 1 regardless of what is in there. So we need to check and make sure that for the very first digit to see if that's a 0 or not. So if, actually, we're going to use an unless here, unless only look at when we're looking at the 0 position. Once we're in this first position and position the 0 and this. My int s equals, we're going to do s position dot to integer. We're going to multiply this by 2. I'm going to take this whole thing and put it to the power of the position. It's a little bit confusing here, but what's going on? So in this line, we're going to say my int, which is here, is going to store in the variable, is going to be plus equal to. So it's going to be equal to itself plus. We're taking whatever is in the position here. So it's going to say we're taking the second one over here, which in position is going to be 1 because it goes 0, 1, obviously. So s position, so that's 0 dot to integer is going to be 0 times 2 to the power of position, which is going to be 1. So when we have this one, which is 3, which is the 4th place, but it's going to be 3 in position. So s position, which is going to be that 1 to integer. So it's 1 times 2. So it's going to be 2 to the power of position, which is going to be 3. So that's going to give us our 8, which makes sense because 1, 0, 0, 0 is 8. And over here, is we're going to be doing that do this all the time unless position is equal to 0, we're in that first position, and position is equal, that the first element is equal to 0. Because if it's equal to 1, we actually do want to go ahead and do this. So that'll give us our integer. And to check that, we can do, first we can do, see, the bottom we're going to have a return false. But we can do puts my int just to make sure that we have this set up right. And we should get that 8. And that 8 is what we were looking for, because that 8 is the 1, 0, 0, 0. So now we're going to get rid of this line and do the final part to check if my int is divisible by 4. Very simply, if my int mod 4 equal to 0, return true, and so we can run this. You can see that 8 is equal to true. However, 9 is going to give us false. So we can check out that property of 2 zeros as much as we like. See that anything with 2 zeros at the end is going to give us true. But now only in the case of 4, if we wanted to change 4, then say we wanted to make it 5. Then that would make this. Then we'd keep having to update how this would work. And this is much easier in terms of upkeep. And that is homework part 2, homework 0 part 2.